Hi everyone, welcome to the guided notes for section 4 on quadratic inequalities, where we take our knowledge about inequalities and we start to apply them to polynomial graphs. So in section 1, pretty basic here, we're back to algebra 1 ideas, and we're just translating the statement a number greater than 4 into words and then giving an example for the solution. In the next one, part B, I'm taking a number that is a number greater than or equal to 5, and so an example would be 5 or 11, etc. C is a little bit more complicated just because it's a single step inequality, so you have one step to solve it, but the idea is the same. In section 2, now I'm going to graph the solution set, so I need an open circle at 4, and I want to graph any number greater than 4. In B, I want to graph any number that is greater than or equal to 5. And then in C, once I've solved that Z is any number less than 1, I put an open circle at 1 and I shade to the left. Okay, so now we take this idea of inequalities as they apply to quadratics, and we put it on an xy plane, on the coordinate plane. Now we're doing this in two variables, x and y. So what I'd like you to do is notice that the graph of f of x equals parentheses x minus 2 squared plus 1. Just as a refresher, I know this is a parabola, right? It's a quadratic. You can tell that by the picture, but let's just review some things here. If it's squared, it's a quadratic. I also know that the vertex is going to be at 2, 1. This is moved, remember, to the right 2 and up 1, and sure enough, here is the vertex at the point 2, 1. All right. In part A, when x equals 3, what is f of x? In other words, f of 3 equals what? Well, when x is 3, the function equals 2. Now we're going to flip this around a little bit. When the function equals 5, so up here where y equals 5, what's a possible value for x? Is there more than one? Yes, there is. In fact, when we start to look at inequalities, we'll find that there's a whole set of solutions. So when we think about inequalities, we're considering a whole broad set of solutions, which means that we need to shade an area. When it was a linear inequality or just a single variable inequality, we were shading to the left or to the right. Now we've got two variables, so what we need to do is thinking about shading above or below the graph when we've got some sort of polynomial or even a linear inequality. So here's the graph of f of x less than or equal to x minus 2 squared plus 1. The vertex is still at the point 2, 1. Still the exact same parabola opens up, etc. Now, with this new graph, what do we need to change about the graph to make it accurate? Well, we need to shade the area that is below the graph, because all of my solutions will occur below the graph because it says less than. I'll have a solid line solid line for my graph because it is greater than or, you guessed it, equal to. So that equal to is what makes for a solid line. So when we come to solving this and finding 2 points that are in this solution set, it could be anything inside of this shaded region. Because of the inequality, it's anything less than the y values on that graph. And because of the equal to sign, it's also anything that exists on the graph itself. Okay, next we've got a couple of examples. All you're asked to do is shade each solution set, so show where that would be. So here's the graph of y greater than or equal to this statement, x plus 3 squared minus 2. All the solutions for this are above the graph, so I'm going to shade inside or above the function. Anything that's below the function is not included in the solution set. Now here in g of x, I'm looking for anything that is less than or equal to this parabola, so I am going to be shading below the parabola any area underneath the parabola, and you could continue to go down like that. And then the last one, I'm looking for h of x. All the solutions are going to be greater than this parabola that's been turned upside down, moved to the right 4, and down 1. So all the solutions for this parabola are in this zone, shaded here. All the y values that will be greater than the parabola, because you can see that if it just kept going this way, all of the y values above it would be part of the solution. Okay, as we move on, we start to put a little bit more of this together. I give you less and less. So, for example, number 1, I'm going to ask you to identify the vertex, which in this case is in blue. In this case, the vertex is at the point, it's been moved left 3, so the vertex is -3, comma, -4. It's been moved to the left 3, and down 4. Now it's a regular parabola that hasn't been stretched. It's just been moved over. And so here's what we're looking at. I want an accurate sketch with at least 3 points. Now I need to look at the inequality. All my solutions are going to be y values that are less than or equal to this function, and so it is all the y values that exist below anything below the graph. Okay, the rest of the examples in section 4 are for you to do, and that is the end of the guided notes for section 4. See you in the next video.